Hey there! In this video we are going to investigate quadratic functions by creating tables and graphs from their standard form equations, and then look at what patterns we can see, as well as identify information and features that are evident. So we're going to take the equation of a quadratic function and look at it with a table so we can see some patterns and information numerically, and then we're going to create a graph from that table so we can see it graphically and visually, and then summarize some of the important information there. So for this first one, what we have is we have a standard form equation. Standard form for a quadratic equation is where you have an x squared term, you possibly have an x term, and you possibly have a constant term on the end. We're going to generate this table using some mental math, and you might look at that and say, well, that's going to be a lot of calculations to do here. We're going to do it mentally so that we don't have to write a whole bunch, but we don't have to go to a calculator to generate everything, because it's going to be not as hard as you think to do this. Squaring numbers, just multiplying it by itself. Subtracting 6 times the number, that shouldn't be too difficult with the numbers we have there, and then adding 5 at the end. So we'll start with the easiest one here, which is 0. That one we'll start with. And so if we think about this here, we'll just write one thing that we can change the numbers for as we get to. If we have 0, 0 squared is 0. 6 times 0 is 0, so we've got 0 plus 5, so that's a 5. If we keep going here down our table, if we do 1 next, 1 squared is 1, minus 6 times 1, so we've got 1 minus 6 is minus 5, plus 5 on the end is 0. If we do our next one in the table there, we have 2, 2, this is 4, this is minus 12, which gives you minus 8, plus 5 is minus 3. Next one in the table there is a 3. We have 9, we have minus 18, which is minus 9, plus 5 on the end is minus 4. Next one we want to put in there, put a 4. So we've got 16 minus 24, which is minus 8, plus 5 is negative 3. Do our next one here, which was a 5. So we've got 25 minus 30 minus 5, plus 5 is 0. Make this a 6. 6, 6, 36 minus 36 is 0, plus 5 is 5. And then down at the bottom here, the 7, if we put a 7 in there, we have 49 minus 42 is 7, and 7 plus 5 is going to give us 12 there. And then I left this one at the top here because putting in a negative sometimes is something that troubles people, and they make mistakes with things, particularly with this squaring here. So you have to think about it. I've got brackets here, and so it's important to know you're squaring the negative. It isn't this. It isn't, you're not squaring a 1 and then putting a negative. When you think about this, it doesn't actually matter whether this is positive or negative for this term, because when you square a number, it's always positive. So when we're doing that, this is going to be 1, right? Negative 1 squared is 1. So we've got 1, and then with this in here, negative 6 times negative 1. That situation, that is going to actually be like adding 6, right? Negative 6 times negative 1, or you could think of it as subtracting 6 times negative 1, subtracting negative 6, if you will. Either way you think about it, the simplest way is just to think of it as this is going to be like adding when there's a negative in there. So we've got positive 1 plus 6 gives us 7, plus 5 is 12 there. All right, so there's our points. We can put them on the graph pretty quickly, hopefully here. This one actually, and this one, if you notice, with those y values of 12, well, they're too tall for my grid here, the grid that I've set up, so we won't put those ones on there. We'll start with this one. 0, 5 is right there, and 1, 0. 1, 0 is going to be there. The next one, 2, negative 3. 2, negative 3 is that one. And keep going down the list here. 3, negative 4 is that one. And next one, 4, negative 3. 4, negative 3. Next one here, 5, 0. 5, 0 is that one. And we've got then 6, 5, 6, 5 is that one. And as we said, these other two here, 7, 12, 7, 12 is off the grid up there somewhere, and negative 1, 12 is off the grid up there, but it's good to know those are there. Now, in the past, when you've graphed linear functions, you see that it's always a straight line. This is obviously not a straight line, but what it is it's going to be a curve that is representative of that function. I'm going to try and draw the smoothest curve I can through here. Since we're drawing it by hand, it's not going to be perfect, but I'll do that much and then I'll turn. You don't see me, but I'm holding my hand on the inside of the curve. I find it easier to create this shape better if I hold my hand on my pen where I'm resting it inside the curve. So that's not great, but it's not bad, I would say. That shape, if it was drawn properly, is called a parabola. It's a parabolic shape. And actually, it's pretty important here. What we should do is put some arrows in the ends of this curve, because as we've seen here, there's points that are off that grid. So it doesn't end at the top there, it keeps going. So putting arrows in the end is saying that thing keeps going, all right? So as we start looking at this, you're going to see some patterns and things like that. This is a pretty important point here. It's actually called the vertex. We can write the coordinates of that point. They are 3, negative 4, coordinates of the vertex. It's here. And so a vertical line through this kind of divides that thing into two, and you see some symmetry to it, right? You see that that point, and that point have the same y values, that point, and that point. And you can see that in the table as well. These two on either side of this vertex have the same y value. These two have the same y value, and these two have the same y value. And those two that are off the grid also do. So that's going to be pretty important symmetry to realize there. And while we have that line there highlighted, that's actually called the axis of symmetry. A vertical line down the middle here, this is called the axis of symmetry for this thing. It's a line of symmetry that the left side and the right side are symmetric across that line. The way you give the equation of a vertical line is everywhere on that line, the x value is 3. Everywhere on that line, the x value is 3, so you just say x equals 3. That's the equation of the axis of symmetry. And something I skipped there was the direction of opening. Well, this curve opens up. The open side of it, the inside of it is up. It's like a bowl that's upright. You're going to see sometimes that it's upside down and it opens down. So we can just say that it opens up. The max or min value. Well, when you're talking about the values of a function, you're talking about the y values. So these values here. And this has a minimum value. The minimum value is negative 4. That's the lowest y value this function gets to. So we're just going to say this has a minimum of negative 4. The next thing, I think you've seen that before, a y-intercept. Well, the y-intercept is where it crosses the y-axis. You could write that the y-intercept is 5. Or if you want to give it as the coordinates of a point, you could do this too. Either one is probably fine depending on what you're doing. I'm just going to leave it as a 5 there. The x-intercept. X-intercepts here, well, there's 2 of them. There's 2 x-intercepts, and again, you could write those as 1 and 5. You could again give them as coordinates of points, which you'd have to say 1, 0 and 5, 0, but I'm just going to leave it as 1 and 5. They're also called zeros. Really what you do is you talk about the x-intercepts of the graph, and you talk about zeros of the function. All of these things represent the function. The zeros of the function, they're called zeros because these 2 points, those are the x-intercepts. Those are also the places where the function is 0. So sometimes you see them called 0. Essentially, you're looking at the same things there. There's a subtle difference between what you're talking about, but that doesn't usually matter too much. The last 2 things here, domain and range. The domain is the possible x values for this function. If you think about it here, if these are going to keep going up and up and up in both directions here, it's going to get wider and wider and wider. Or another way to think about it is we use these x values, but if we wanted to, we could continue this down and pick bigger and bigger x values and pick more and more negative x values, and we could have put any of those in there. Really here, we could have chosen any x value and substituted it in here. So our domain for this is all real numbers, and I am just going to write that with words. You may have written that before with symbols, and if you want to write it with symbols, just make sure you know what the symbols are and what they mean. X is an element of, that sort of half circle with a line in it is an element of, and R with 2 lines on it stands for real numbers. Don't just write XER. I've seen lots of people that think that's an E and then that this is a regular old R. So if you're going to use symbols, make sure you're doing it properly. I like to just stick with words there. And then as far as the range goes, the range is the possible y values. And as we looked at before, this was the minimum. So our range is going to cover everything from -4 and up. So we're looking at values of y that are -4 and greater. So how we can write this is we can say that y is greater than or equal to -4. All right. So maybe before we leave this, another thing to notice is numbers that come up in multiple places here. So the coordinates of the vertex, those numbers, 3 and -4, well, 3 comes up in a couple of places. That 3 also is the same as that, right? Because the vertex is also where the axis of symmetry crosses. Those will always be the same. The x-coordinate of the vertex is going to match the number in the equation of the axis of symmetry. And another number that comes up, this -4, that comes up in 3 different places there, right? Because when you're talking about the coordinates of the vertex, the y value is going to be either the max or the min for the thing. In this case, it's the minimum because it is the lowest one. And then it's also going to come up in the range because that's where the y values, all the possible y values start. So you see things that come up more than once there. It's good to make those connections. All right, let's look at another one. So in this second one, we still have the equation of a quadratic function that is in standard form. There's still 3 terms to it, but this time the big difference is the x² term has a negative in front of it. So we can still do mental math with this, although some people run into problems sometimes with that. The thing to remember here is x², when we had that before, it was always positive because we were squaring the negative. x² is always positive, so if there's a negative in front of it, you're making it negative after you square it. So x² was always positive, negative x² is always negative. And so when we think about this here, we can think about negative something squared, it's always going to be negative. And then this was like the one we had before, we had negative something times our x value. So if we have -2 times our x value, and then we have the 8 on the end, we can still do this with mental math here. If we start from top to bottom, might as well tackle these negatives first. If we have our -5 in there, in those 2 spots, the way to think about this is, I mean, that's a lot of negatives there you're looking at, but just recognize this is positive. So with that negative in front, it's negative. So 25, it's going to be -25. So this is -25, and this we have -2 times -5 like before. That's plus 10. So we got -25 plus 10 is -15, plus 8 is -7. All right, and we can probably cruise through the others fairly quickly too. If that's a 4 in there, this is -16. This is plus 8, so that gives us -8. -8 plus 8 on the end is 0. If we put our third value in there, which is -3, we have -9 plus 6 is -3. -3 plus 8 is 5. If we put our -2 in there, we've got -4 plus 4 is 0, plus the 8 gives us 8. And put our -1 in there, our last -1. -1 plus 2 is 1, plus 8 is 9. And we'll put our 1 in there that's often the easiest one in standard form is putting a 0 in there because we've got 0 minus 0. The whole thing is 0, and you're just left with plus 8 there. So that's an 8. And keep going down here. We've got into positive numbers now. So we've got -1 squared, and then the negative makes it negative. We've got -1 minus 2, so -3 plus 8 is 5. We'll put our 2 in there. -4 minus 4 is -8 plus 8 is 0. And the last one there is a 3. So we've got -9 minus 6 is -15 plus 8 is -7. So maybe even before we finished this table, you started to see some of the symmetry. Those numbers are the same. Those y values are the same there and there as well. Now, when we graph it, you're going to see, spoiler alert here, this is actually going to be the vertex around that point, and the other values you'll see will be symmetric around that. So maybe what we'll do is graph it that way. We'll graph this one first. -1, 9 is up here. That's that. And then we'll graph the ones around that. So we'll graph these two. So we'll graph 0, 8 is right there. And -2, 8 is right there. That's symmetry. We'll graph our next two symmetrically there. Those two. So -3, 5 is there. And 1, 5 is here. And then the next pair that we can fit on there, this one's going to be over here, -4, 0. And we have on the other side 2, 0. And then just like the one before, we have the last couple here that don't fit on the grid, but we know they're there. And again, I'm going to try and draw a nice smooth curve through this, like this. Again, it's not going to be great, but it's going to be hopefully not too bad. All right, that's not, again, not great, but it's okay. It'll work for what we're looking at here. You get a rough idea of what that shape looks like. Again, putting arrows in the end to indicate that the function keeps going and that there are points, you know, say those two, that are off the grid but are part of the function. So let's write down our information here. We, of course, have our vertex, that point, which is right there, which is -1, 9. Our direction of opening, this time it's opening down. The concave side of the thing is down, if you will. So we're going to say this opens down. It's like an upside down bowl. Our axis of symmetry, that line down the middle, again connected to the x value of the vertex, -1. And so we're just going to say as the equation, x equals -1 is that equation. This has a maximum value this time. There's a top to the thing. The highest value this goes to is 9. So we're going to say this has a maximum of 9. Our y-intercept right there is, of course, 8. I'm just going to write it as an 8. Again, you could write it as 0, 8 if you like. X-intercepts, again, there's two of them here. Crosses twice, that and that. So we've got -4 and 2. Again, you could use coordinates. I'm choosing not to. Domain and range. Again here, the domain is all real numbers. This would keep getting wider and wider and cover all those values. We could have picked anything here. So again, we're going to say all real numbers for this. And then the range here is going to be connected to this, the fact that it has a maximum of 9. So it means 9 is the highest. So it's going to be 9 and lower. So the way we're going to say this is we're going to say that y is less than or equal to 9. All right, so that is essentially it. That did take a fair amount of time to do all of this with those two different quadratic functions, but hopefully in the process you picked up a variety of different things between working with that mentally to generate the table of values and realizing it's not as hard as you might think, and then seeing some patterns in the table of values and seeing how they are reflected in that graph, and then coming up with this different information from the table and the graph. All right, that's it.